హాయ్ ఎవ్రీబడి వెల్కమ్ టు ఎస్ఎంఆర్ తెలుగు ఎడ్యుకేషన్. ఈ వీడియోస్లో మనం ఏం డిస్కస్ చేద్దామంటే పాయింటర్స్. ఓకే, సో వాట్ ఈజ్ ఎ పాయింటర్? సో pointer is a variable which can store the address of another variable. Okay, in pointers concept we have to discuss the operators called address of operator and then asterisk. In these two operators we have to discuss it in pointers concept. Okay, so pointer is a variable which can store the address of another variable. Okay, so what is this operator? Is called address of operator. Address of operator. Another operator is called asterisk. Another operator is asterisk. So asterisk is a address of. Asterisk is called indirect operator. Indirect operator or dereference operator or object at that location. Object at that location. Object or variable, both are same. Variable at that location. So in pointers concept we have to discuss two operators. First one is address of operator and another one is asterisk. Asterisk is the indirect operator or dereference operator or object at that location. Okay. So what is the meaning of int a? So what is the meaning of int a? Here a is a variable. So what is the meaning of int a? Here a is a variable of type int. In a we can store integer value. Okay. Similarly, what is the meaning of pointer can be declared by using int asterisk ptr. So this is a ptr is a variable of type int asterisk. Ptr is a variable of type int asterisk. So in a we can store integer value. In ptr we can store integer variable address. In ptr we can store integer variable address. Integer variable address. So in ptr we can store integer variable address. Okay. Sometimes you have to declare the pointer as int space asterisk space ptr, int asterisk space ptr, int space asterisk ptr. Okay. So all the meaning is same. So all this meaning is same. Okay. Here we are mixing these two values. Asterisk ptr is which type of variable? Int. Here a is which type of variable? Int. Similarly, asterisk ptr is which type of variable? Int. So asterisk ptr always gives integer variable. So asterisk ptr always gives integer variable. So asterisk ptr always gives integer variable. So in ptr we can store integer variable address. So asterisk here a is asterisk ptr always here a is which type of? In a we can store integer value. In similarly in asterisk ptr we can store integer value. Okay. So asterisk ptr always gives integer variable. Okay, we have to discuss this one with an example. So I'll write small example. So void main. Here we are declaring two variables. One is a of type integer, another one is int asterisk ptr. Here I am assigning 10 into a. So here the ptr is a pointer variable. In ptr we can store integer variable address. A is a variable of type int. So address of a, here asterisk ptr is equal to 20, and then printf percentage d comma a comma asterisk ptr. Okay, see in C language every variable has some name, some address and some initial value. Okay, here a is a variable. So variable name is a, some address, every variable has some address. Some address is I will take 500. Okay, so address are nothing but unsigned int values. Address is in between 0 to 65,535. Okay, we have to take any value in between 0 to 65,535 as an integer. Here I am taking 500. Okay, next ptr is a one type of variable. Every variable has some name. So name is ptr, some initial value and some address. I will take address is 600. Okay, here a and ptr are auto variables. Auto variables default value is garbage value. Here the value of a is initial value is garbage value. Here ptr is also garbage value. So garbage value means it will take any value. Okay, any value of int. Here any value of int. Okay, next this statement is executed. Here 10 is assigned to a. So here the value of a is 10. Here this value is a value is 10. Next this statement is executed. Here what is a? A is 10. What is address of a? 500. Here the pointer is a variable which can here this is the pointer variable. So pointer is a variable which can store the address of another variable. So here the address of a is 500. This 500 is stored in ptr. This is 500. Okay, so this one is very important. So this statement is very important. What is the asterisk ptr? Okay, in C language I will take a small example. So a is equal to 2 plus 3. A is equal to 2 plus 3. So in this statement first how many operators are there? Assignment and plus. Here the first plus is executed. 2 plus 3 the value is 5. So this one is replaced with 5. This 5 is assigned to a. So in C language every operator should return a value. Here the plus operator returns the value. The return value is 5. Here I am taking another statement. 2 is equal to 2 into 3. So this is a multiplication. This operator also returns a value. 2 into 3 the value is 6. The return value is 6. That 6 is assigned to a. So the value of a is 6. Okay, in C language every operator should return a value, but here the asterisk is the operator Here the asterisk is the operator that returns so asterisk is the operator that returns object at that location or variable at that location. Okay, here what is the ptr? The ptr value is 500. Okay, asterisk ptr means asterisk operator returns object at that location. Okay, the ptr value is 500. What is the object at that 500? That 500 address variable or object is a. So that's why this is called indirect operator or dereference operator. Indirectly this operator returns a. Okay, so here value of a is equal to 20. So what is the value of a? So value of a is 20. Here the 10 is replaced with 20. Okay, so next one is this statement is executed. Okay, what is the value of a? Value of a is 20 space. What is ptr? Ptr is 500. What is asterisk ptr? Object at that location or variable at that location. 500 address variable is a. So that's why this is called indirect operator. Indirectly this is called 20. Indirectly this is called a. What is the value of a? Value of a is 20. Okay, so asterisk ptr always gives integer variable. Okay, so this is pointer declaration. We can access. Okay, so we have to take this one an example. I will execute this code. Okay, here how many variables I have to declare? A into asterisk ptr. Next a is equal to 10. So ptr is equal to address of a. So asterisk ptr is equal to 20. Printf percentage d comma a comma asterisk ptr. Save this file with the .c extension. So pointer .c. Okay. Okay. So we have to debug this code. How to debug? Our C program is always executed from top. Okay. That's mean main method. Always execution starts from main. Okay. So execution start here. I want in this body how many variables you have to declare? A and ptr. Okay. You have to add a and they have to add ptr. Okay, now the execution is not started. Okay, that's why the undefined symbol a, undefined symbol ptr. Whenever the control goes to this body, the memory is allocated for a and into a and ptr. So a initial value is some garbage value, ptr initial value is garbage value. Whenever this statement is executed, 10 is assigned to a, value of a is 10. Next, what is the ptr? Ptr is a pointer variable. In ptr we can store integer variable address. Here a variable address is yes stored in ptr. Okay, next, what is asterisk ptr? So asterisk ptr is a object at that location. Here the ptr is address of a. Asterisk ptr means indirect operator a. Indirectly this is a. So a is equal to 20. So whenever this statement execution is completed, 20 is assigned to a. Here the a value is changed, value of a is 20. Here the value of a is 20. Next, this statement is executed, value of a is 20. What is ptr? Ptr is a pointer variable. What is the address in ptr? Address of a. What is asterisk ptr? Returns indirect operator, indirectly a. The value of a is 20. 20 space 20 is printed. Okay, alt F5. So 20 space 20. So whenever the execution is completed, the control goes to out of this body. Then this memory is deallocated. A and ptr are undefined symbols. Okay, a ptr are undefined symbols. Okay, so I will give small example. So save this file as pointer2 dot c. So void main. Here I am taking two variables into a, b. Here I will taking one pointer variable ptr. So a is equal to 10, b is equal to 20, ptr is equal to address of a, ptr is asterisk ptr is equal to 30, ptr is equal to address of b, asterisk ptr is equal to 40. So printf percentage d percentage d comma a comma b comma asterisk ptr. Save this file. Okay, so in this code we have to define how many variables a, b and ptr. Okay, so here the memory is allocated for a, b and ptr. Here the memory is allocated for a, and then b and then ptr. So every variable has some name. I will take this variable name is a and this variable name is b and this variable name is ptr. So every variable has some address. I will take this variable address is 500, this variable address is 600, this variable address is 700. Some initial values is garbage value. Here the initial value is garbage value. Here the initial value is garbage value. Okay, next this statement is executed. Here the value of a is 10, value of b is 20. Okay, so a value is 10, b value is 20. ptr is equal to address of a. Okay, here the value of a is 10, here the value of b is 20. Okay, so ptr is equal to address of a. What is the address of a? Address of a is 500. So initial here the garbage value is replaced with 500. Okay, now the pointer is pointing to this one. Okay, so what is ptr? 500. What is asterisk ptr? 500. Asterisk ptr means what is ptr? 500. Asterisk ptr means 500 address variable is a. This is indirect operator. That means indirectly a is equal to 30. Next this statement is executed indirectly. ptr is 500, asterisk ptr is 500 address variable, that is a. So a is equal to 30. Here this value is replaced with 30. Okay, next, so ptr is equal to address of b. B is 20, address of b is 600. So this 600 is stored in ptr. So this one is replaced with 600. Okay, so next this pointer is removed. Now, what is the PTR? What is the PTR? PTR is 600. What is asterisk PTR? 600 address variable. 600 address variable is B. Indirect operator B. That means indirectly B is equal to 40. So this one is replaced with 40. Okay. So now what is the value of A? 30. What is the value of B? 40. What is asterisk PTR? PTR is 600. Asterisk PTR is 600 address variable indirectly B, that is 40. Okay, I have to run this code. So the output is 30 space 40 space 40 is the output. Okay, so alt F9, yes, control F9, output is alt F5. 30 space 40 space 40. Okay, the 2020 is so before program output. By using CLR SCR, you can clear the screen. The output is alt F5, output is 30 40 40. Okay, so I will explain this one with step by step every variable by how to debug this code. Okay, first you have to learn how to debug the code. So A, B, PTR. So execution is always starts from top to, or C program execution is always starts from main method. Okay, so whenever the control goes to inside the body, memory is allocated for A, B, PTR, A, B, PTR. Okay, A value is 10, B value is 20, PTR value is address of A. Next, asterisk PTR is equal to 30. That means indirect operator. This is A. PTR is 500. Asterisk PTR is 500 address variable A. So A value is A. A is equal to 30. So A value is 30. Next, PTR is equal to address of B. B is 30. Sorry, B is 20. Address of B is 600. Okay, so PTR is 600. Asterisk PTR is 600 address variable indirectly B. So B is equal to 40. So whenever completion of this statement, B value is 40. Okay, so what is the A value? 30. B value 40. Asterisk PTR. PTR is 600. Asterisk PTR is 600 address variable B. So 40. So alt F5, 30 40 40. Whenever completion of this code, whenever control goes to out of this body, the memory is deallocated. Undefined symbol, undefined symbol. Okay, so this is pointers. Still you have any doubts, please discuss with your friends. Okay, so thank you for watching.
హాయ్ ఎవ్రీబడి, వెల్కమ్ టు ఎస్ఎంఆర్ తెలుగు ఎడ్యుకేషన్. ఈ వీడియోలో మనం ఏం డిస్కస్ చేద్దామంటే సైజ్ ఆఫ్ పాయింటర్స్. ఓకే, సో వాట్ ఈస్ ద సైజ్ ఆఫ్ క్యారెక్టర్ ఈజ్ 1 byte, ద సైజ్ ఆఫ్ ఇంటీజర్ ఈజ్ 2 bytes, ద సైజ్ ఆఫ్ ఫ్లోట్ ఈజ్ 4 bytes. నౌ వీ హ్యావ్ టు డిస్కస్ వాట్ ఈస్ ద సైజ్ ఆఫ్ పాయింటర్. Here I am declaring int a is equal to 10. So in this, the a is a integer type of variable. The memory is allocated for 2 bytes. So the size of int is 2 bytes. The variable name is a. Every variable has some address. I will take 500 is 1 byte. 501 is another one. Okay, 500 is 1 byte, 501 is so 501 is another byte. Okay, for integer memory is allocated for 2 bytes. Here I am declaring int asterisk ptr is equal to address of a. Here the memory is allocated for ptr. The memory of is 2 bytes. So the memory is 2 bytes. So the memory is allocated for 2 bytes. So variable name is ptr. Variable name is ptr. So memory is 2 bytes. This one is 1 byte. This one is another byte. So 501 and then 500. So our number system is from right to left. That's why first byte is this one is second byte. Okay, next one is I will take the character. Here I am declaring int or char ch is equal to within the single quotes a and char asterisk cptr character pointer is equal to address of ch. Here the memory is allocated for ch. Here the character size is 1 byte. So the memory is allocated for 1 byte. So every variable has some name. That name is ch and the address is I will take 500. Okay. So next you have to assign the character variable address 500 into the variable is called cptr. So the memory is allocated for cptr. So this one is first byte, second one is second byte. So I will take 500 or I will take okay same name, not problem, 500, 501. Here I am taking 500, 500. Okay, so if you want you can take different address. Take here I am taking 600. This one is 601. Okay, next address of ch is 500. 500 is stored in address of cptr. Okay, so next one is I am declaring float. Float f is equal to some value assign 10.5 f, and then I will declaring float pointer float asterisk fptr is equal to address of f. Here the memory is allocated for f is float size is 4 bytes. That's why memory is allocated 4 bytes. This is 2 bytes. We are taking another 2 bytes. Total 4 bytes. Here the variable name is f. Here I am taking starting address. Total 4 bytes. So first byte, second, third. Okay. First byte address is 500. 500. So next byte is 501. Next one is 502. Then 503. 503. Okay. Here the memory is allocated for float pointer. Okay. The float pointer size is 2 bytes. So first byte and then second byte. variable name is fptr. So fptr. Here the starting address is 500, and then next address is 501. 501. Okay. So please observe the size of integer is 2 bytes, the size of character is 1 byte, the size of float is 4 bytes. But the size of integer pointer is 2 bytes, the size of character pointer is 2 bytes, the size of float pointer is 2 bytes. So the size of all pointers is equal. Okay, so please note this one. The size of all pointers is same, so that is 2 bytes. 2 bytes. Okay, right. Next we have to discuss the size of pointer with the good example. Void main so int a is equal to, here I am assigning 511. Next char asterisk cptr. Here I am taking character pointer cptr. Here I am assigning another integer variable. Okay, so default value is garbage value, no need to assign. Here I am taking char asterisk character pointer is equal to address of a. Next b is equal to asterisk ptr. Next asterisk ptr is equal to 10, and then printf %d comma a comma b comma asterisk ptr. So what is the output of a given program? Okay, in this example we are declaring how many variables? 3 variables, a, b, c, ptr. The memory is allocated for 3 variables. A. So integer size, a is which type of variable? Integer. The size of integer is 2 bytes. Variable name is 500. This is first byte. This one is the second byte. Here I am taking first byte address is 500. Next byte address is 501. Next int b. Here we are declaring another variable b. So variable name is b. Some address. Here I am taking some 600. So initial value is garbage value. So int a is equal to 511 is stored in a in bytes. Okay, so please convert 511 into binary form. We will get the following result. So every byte has 8 bits, 0000001. 8 bits, next 111, and then 111. Okay, so whenever you have to convert the 511 into binary form, the following in memory it is stored like this. Okay, next char pointer. Here I am declaring, so cptr character pointer address is 2 bytes. So variable name is cptr. So here I'm taking some address 700. In cptr, it stores the address of A. So please remember. So what is the A? A is 511. So what is the address of A? Here the address of A is 500 and 501. Okay, this is the first byte. This one is the second byte. So the first address is stored in the cptr. The first address is 500. So value 500 is stored in cptr. So that means cptr is pointing to first byte. So cptr is a character pointer. In character pointer, we can store integer variable address. This is valid statement. Next, b is equal to asterisk ptr. So please remember. Sorry, ikkada you have to take cptr. Instead of taking cptr, here you have to take simply ptr. Okay, so asterisk ptr. What is ptr? Ptr is 500. Asterisk ptr. Asterisk ptr is 500 address variable. That is, what is the size of character? Here the size of character is 1 byte. That's why this statement asterisk ptr returns object at that location or variable at that location. 500 address location is this one. It simply returns 1111 in B. So in B is replaced with 1111 space 111. This 8 bits is stored in B. Okay. If this value is equal to -1, this equal binary form to integer value is equal to -1. This total thing is replaced with -1. So what is the value of B is -1. So please observe, here we are taking character pointer. That's why that pointer returns single byte, first byte. That value is stored in B. Next, asterisk ptr is equal to 10. Here we are assigning 10 value into asterisk ptr. What is ptr? Ptr is 500. Asterisk ptr means this value. This value is replaced with 10. 10. So convert the 10 value into binary form. The equivalent value is 0110. So total first 4 000110. 8 bits, 4 bits, 2 bits, 0. This value is 10. 10 equivalent binary form is this one. So this one is 0 into 2 power 0 into 1 into 2 power 1. This value is 1 into 2 power 8. That value is equal to 256. 256 plus 10. The value is 266. So in A, this total value is equal to 266. So what is the value of A? Value of A is 266 is printed space. Here B. What is the value of B? -1. So -1 is printed. What is PTR? PTR is 500. What is asterisk PTR? Object at that location. The PTR is which type of pointer? Character pointer. Character size is 1 byte. That's why it returns only first byte. The first byte value is 10. We run this code, the output is 266 space minus 1 space 10. So we want to execute this code. Void main. So here please remember the size of all pointers is equal. The size of character is 1 byte. The size of integer is 2 bytes. The size of float is 4 bytes. But it is a character pointer or integer pointer or float pointer. All pointer sizes are equal. So int a is equal to 511 int b. Here I am taking char asterisk ptr. The ptr is equal to address of a. So b is equal to asterisk ptr. The asterisk ptr is equal to 10. Then print percentage d space percentage d space percentage d comma a comma b comma asterisk ptr. So save this one, compile. So we will get a warning where there is some warning 1 1. That warning is we are assigning integer pointer is to the character pointer. Read this one. So warning is not a problem. Just run this code. Control F9. So Alt F5. So output is 266 minus 1 and then 10. So here instead of character we are taking integer. Okay, it is similar to first example. Nothing but it returns 2 bytes of memory. Asterisk b is 211 511. B is asterisk ptr means it returns 2 bytes of memory. That means b is 511. In asterisk ptr it is 10. That means a value is replaced with 10. We run this code. A value is 10. B value is 511. Asterisk ptr is nothing but a, that is 10. We have to run this code. Control F9, Alt F5. So output is 10, 511, 10. So here the please here important concept is we can assign character pointer. Char asterisk ptr returns single byte, not 2 bytes. So please remember the sizes of all pointers are equal. Okay. So thank you for watching. So hi everybody, welcome to SMR Telugu Education. So ఈ వీడియోస్లో మనం C language pointers concept discuss చేస్తాం. So next topic is, so last video we have to discuss what is the size of pointer. So next concept is what are the operations allowed on pointers. Operations on pointers. So here I am taking the small example. Here the pointer p1 is equal to, pointer p1 is one integer type of variable. Here I am taking another pointer variable p2. P2 is another integer pointer. So p1 is one pointer, p2 is another pointer. Here I am taking p1 value is 500 and p2 value is 600. Here I am adding two variables, pointer variables p1 plus p2. p1 plus p2, then we will get an error. So addition operator is not allowed in between pointers. Whenever you try to add two pointers, we will get an error. So p1 is, if the p1 is one address, p1 is one address, p2 is another address. So p1 and then p2. So addition is not possible, then we will get an error. I will ask you one question. Your next address whenever we are adding pointer to one value, it represents next address. That means next address of the p1 is one variable. We have to add one means we are next address value, that is next address. For suppose in integer the size is 2 bytes, the first byte is first address is 500. We are adding plus 1 means next address is 502. Next, addition of one value is allowed. Next, p1 plus 2 allowed. Next address, next address. Next, p1 plus p3 3. That means next two values allowed, valid. p1 plus some x. అలా మనం you have to add continuously up to somewhere you have to get p2. Some address in middle. Okay, next from this equation you have to write p2 minus p1 is equal to x. So can I subtract p1 minus p2 is equal to some x? That means in this some addresses are there. So this one is p1, this one is p2, this address is p1, this address is p2. Whenever you have to subtract these value into this value, it gives the remaining elements in between p2 and p1. So the subtraction of pointer variables is allowed. This one is valid. It gives the elements in between p2 and p1. Okay, in arrays concept, in arrays and strings, we are using all these operations. So addition of 2 pointers is not allowed. Whenever we are adding one value, we will get the next address. We are adding so we are adding 1, it is pointing to this address. Next we are adding 2, we are pointing to this address. We are adding 3, pointing to this address up to some addresses, then we will get the p2. The difference of p2 minus p1 gives the addresses between p2 and p1. Next, so can I subtract one value from the pointer? So p2 minus 1, this is p2. Whenever we are subtract one value, it pointing to previous address. So p2 minus 1 means this value is pointing to this address. Next, p2 minus 2, it is pointing to next address. Okay, so can I add one single value into pointer? Yes, it is pointing to next address. Can I subtract one value from the pointer? Yes, it is represents the previous address. Can I subtract 2 pointers? Yes, valid. It gives the number of addresses in between the p1 and p2. So these are the operators allowed on pointers. Next, can I multiply one value pointer with a single constant value? So p1 into 2, this is invalid. So we will get an error. So can I subtract one pointer into another pointer? Sorry, can I divide one pointer into another point? No, not allowed. Not valid, invalid. This one also invalid. So can I divide modulus of one pointer to another pointer? Invalid.
So can I divide one single pointer into a constant? This is also invalid. So these are the operators not allowed on pointers. The only allowed pointers. So then I compare two pointers. P1 is double equal to P2. This one is valid. So both addresses are pointing to same value or not. It will check P1 address and P2 address are both are equal or not. This one is valid. So these are the only operators allowed on pointers. So +1 plus some constant value. +1 is pointing to next address. -1 is pointing to so previous address, and then double equal is allowed to compare the two pointers. Multiply with constant value, divided with the constant value, modulus operators, these are not allowed. So by clearly you have to understand this with an example. So void main. Here I am taking so long int variable, long int size is 4 bytes. Here I am taking hexadecimal representation is start with 0x 1 2 3 4 5 6 7. Here I am taking character pointer char ptr is equal to address of so long int some variable name a is equal to this is the value. So char ptr is equal to address of a. Here I am adding ptr plus plus. So ptr plus plus. So in this here we are adding +1 means plus plus increment operator is equal p1 plus plus is equal to p1 plus 1. p1 minus 1 is equal to p2 minus 1 is equal to p2 minus minus. So subtraction is allowed and addition is allowed. Subtraction gives the next address. Sorry, addition gives next address. Subtraction gives so previous address. Same printf percentage x for hexadecimal form asterisk ptr. Right. So the size of long int is 8 bytes. The memory is allocated for 8 bytes. 8 bytes. Here I am taking this one is the first byte. This one is the second byte. This one is the third. This one is fourth. Here I am taking the addresses 500, 501, 502, 503. 502, 501, 500. So this is hexadecimal representation. 78 is stored in binary form, but here I am writing integers. 7 is 0, 1, 1, 1. 8 is 1, 0, 0, 0. Similarly, 5, 8. Directly I am writing integer value is 5, 8. 5 is stored in 4 bits. 6 is converted into 4 bits. So better to write so 5, 0, 1, 0, 6, 0, 1, 1, 0. Next 3, 4 is stored into 3. Stored in next byte. 3, 4 is 0, 0, 1, 1. 4 is 0, 0, 0, 1, 0, 0. So similarly 1, 2. 1 is 0, 0, 1. 2 is 0, 0, 1, 0. So these values are stored like this in the memory.
Next, what is size of char is 1 byte. The size of character pointer is 2 bytes. Here the memory is allocated. Here the variable name is A. Here the variable name is ptr. So ptr, some address I will take 600. So in ptr is equal to address of A. What is A? This one. What is the address of A? The base address of A. Base address of A is 500. This 500 is stored in this variable. Right. Next. So here we are using ptr plus plus. That means the pointer is pointing to next address. What is the size of char? Is 1 byte. Whenever we are using the character pointer increment, the character size is 1 byte. That's why whenever this statement is executed, this value is replaced with 501. Now this pointer is 501. So character next, the ptr plus plus means the pointer is pointing to next address. That next address is 501. Okay. Now once again we are using, once next this statement is executed, ptr plus plus. That means the pointer is pointing to next address. Next address is 502. This one is replaced with 502. Now this pointer is pointing to 502. Next, this statement is executed, printf percentage x. Percentage x is hexadecimal form. Here ptr means 502, asterisk ptr means 502 address value, that is this value. This value is 3 4. So output is printed 3 4. Okay, I have to run this code. So I will take new file, save this file with .c extension. So operate some name .c. Here I am taking void main. So long int a is equal to 0x12345678. This is hexadecimal. So char asterisk ptr. So ptr is equal to address of A. So ptr plus plus ptr plus plus. Printf percentage x star ptr or asterisk ptr. To run this code, here I am clear the screen, clr scr. So I want to run this code. So output is 3 4. So alt F9. Yes, warning. Warning is not a problem. Here we are assigning long int pointer to here long int pointer, long int variable address to character pointer. That's why we will get a warning. No problem. Next, run this code. Alt F5. Control F9. The output is alt F5. The output is 3 4 34.
Okay, right. So instead of here I am taking character pointer, you are take integer pointer, I am taking just one ptr plus plus. Now the size of pointer is 2 bytes. That's why whenever we are incrementing ptr plus plus, in this case here we have to change integer pointer, integer size is 2 bytes. Now we have to take this one is the first byte, this one is the second byte. Whenever we are increment the integer pointer pointing to next address. Next this value is printed, this value is 1 2 3 4. In this case you have to run this code, the output is 1 2 3 4, alt f5 1 2 3 4. See, the concept is what are the operators allowed on a pointers. Okay, whenever you have to increment the pointer we will get the next address, whenever you have to decrement the address it get the previous address. So thank you for watching.
హాయ్ ఎవ్రీబడి, వెల్కమ్ టు ఎస్ఎంఆర్ తెలుగు ఎడ్యుకేషన్. ఈ వీడియోస్లో మనం ఏం డిస్కస్ చేద్దామంటే లెవెల్స్ ఆఫ్ పాయింటర్స్. లెవెల్స్ ఆఫ్ పాయింటర్స్. There int a, int asterisk ptr, int asterisk asterisk pptr, int asterisk 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 pptr. Here a is equal to 10, ptr is equal to address of a, pptr is equal to address of ptr, ptr is equal to address of ptr.
Next, so next, what is the value of a? ptr, so address of a, address of ptr, asterisk ptr, pptr, address of pptr, asterisk pptr, asterisk asterisk pptr, pptr, address of pptr, asterisk pptr, asterisk asterisk pptr, address asterisk 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 pptr. Okay, here the variable name is a. Every variable has some name a, some address. Here I am taking 500. Initial value is garbage value. This one is int asterisk ptr. So variable name is ptr, some address. I am taking 600. So initial value is garbage value. Next, int asterisk asterisk pptr. Here variable name is ptr, some address 700. Initial value is garbage value. Next, int asterisk 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 pptr. So variable name is pptr, some address 800. So initial value is garbage value. So a is equal to 10. So value of this garbage value is replaced with 10. Next, ptr is equal to address of a. Here a value is 10, address of a is 500. That 500 is stored in ptr So this PTR is pointing to this address. Next, PPTR is equal to address of PTR. Here PTR is 500, address of PTR is 600. The 600 is stored in PPTR. So this garbage value is replaced with 600. So this pointer is, this one is 600 is pointing to this location. Next, PPTR is equal to address of PPTR. Here PPTR is 600, address of PPTR is 700. The 700 is stored in PPTR value is 700. Now this variable is pointing to this one. So these are the levels of pointers. Okay, this is single pointer, this is double pointer, this is a triple pointer, or so on. Any levels of pointers are allowed in C language. Now what is the value of A? So what is the value of A? Value of A is 10. So what is the PTR? PTR is 500. What is the address of A? Here the address of A is 500. What is address of PTR? This one is PTR. This one is address of PTR. Address of PTR is 600. What is asterisk PTR? So what is asterisk PTR? So PTR is 500. Asterisk PTR is 500 address variable, that is A. Indirectly A. What is the value of A? 10. A, this value is 10. Next. So what is PPTR? PPTR is 600. What is address of PPTR? PPTR address is 700. This value is 700. Okay, so what is asterisk PPTR? What is asterisk PPTR? What is PPTR? PPTR is 600. PPTR is 600. 600 address variable, that is PTR. Asterisk PPTR is indirectly is equal to PTR. So indirect, what is the value of PTR? Is equal to 500. Next, first it is replaced asterisk PPTR. How this one is evaluated? First it is evaluated as asterisk PPTR. PPTR is 600. Asterisk PPTR is 600 address variable. Indirectly this one is returns PTR. That means this value is equal to asterisk PTR. Next one is, this one is evaluated. What is PTR? PTR value is 500. Asterisk PTR is 500 address variable, that is A. Indirectly this one is equal to A. A value is 10. So this one is replaced with So this one is replaced with A. So A value is equal to 10. So asterisk asterisk PPTR value is equal to A. Next. So PPTR value is 700. So this value is equal to 700. Next, address of asterisk address of PPTR address is 800. This value is equal to 800. So what is asterisk PPTR? So PPTR value is equal to 700. Asterisk means 500, 700 address variable, that is indirectly P. This value is indirectly PPTR. That means PPTR value is 600. Next, up to this is equal to PPTR is 700. Asterisk PPTR is 700 address variable, that is indirectly this is equal to that returns PPTR. So PPTR is 600, asterisk PPTR is 600 address variable, that indirectly it is PTR. Indirectly this is PTR. The PTR value is equal to 500. So this value is equal to 500. Next, up to this so PPTR value is 700. Asterisk means 700 address variable PPTR. Indirectly up to this it returns PTR. PTR. So asterisk PPTR is 600. Asterisk PPTR is 600 address variable. Indirectly that is PTR. So this value is up to this value is PTR. This value is equal to PTR. Next it is evaluated as asterisk PTR. Indirectly asterisk PTR is 500. Asterisk PTR is 500 address variable, that is indirectly A. That value is equal to 10. So these are the levels of pointers in C language. So here I am taking void main. So variables are int A, int star PTR, int star star PPTR, int star 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 or asterisk 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 PTR. A is equal to 10, PTR is equal to address of A, PPTR is equal to address of PTR, PTR is equal to address of PTR, and then printf %d comma A comma address of A. The address of A can be represented by using format specifier is U, percentage U. Here the printf. So run this code, Alt F9, Control F9, Alt F5. Output is 10, address is 65,524. Here I am using CLR SCR. Here printf percentage D, comma, asterisk PTR. Asterisk PTR is indirectly A. So percentage U, comma, address of PTR. Then I am printing. Here I am using /n for every /n. So /n percentage D, comma, asterisk asterisk PPTR. Indirectly this is A. And then percentage U, so asterisk PPTR is nothing but PTR is address. Once again you are using percentage U, comma, address of PTR. Next I am writing printf /n percentage D, address of asterisk 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 PTR. This value is indirectly is equal to A. Next here I am writing percentage U, comma, asterisk asterisk PPTR. So asterisk PPTR indirectly address. That's why here I am writing percentage U, comma, asterisk PTR. This is also address. That's why here I am writing percentage U. Once again percentage U, comma, address of PTR. So Alt F9, yes, Control F9, Alt F5. This one is the output. Here you have to write asterisk asterisk PPTR. This one is address. This one is A value. So asterisk PTR is also A value. This one is also A value. Okay. So Alt F9, yes, Control F9, Alt F5. Output is this one. So these are the levels of pointers. Any levels you have to take. Okay. Thank you for watching. Bye.
Hi everybody, welcome to SMR Telugu Education. So next concept is what is call by value, what is call by reference. Okay, so what is the output of a given program? Void return type, function name is SMR, no parameters, into t is equal to a is equal to b is equal to t. Here I am declaring main function, return type is void, function name is main, so no parameters. Here I am declaring two variables, int a initial value is 10 and b is equal to 20. Here I am calling SMR function name and then print printf percentage d space percentage d comma a comma b. So what is the output of a given program? So what is the output of this program? Okay, we have to run this code, we will get an error. Here there is one function called main. The name of the function is main. In this main function we are declared two variables. One variable name is a, another variable name is b. So here every variable has some name. So variable a, variable b, this one is a, this one is b. So every variable some address I will take 500 and this variable address is 600. Here we are assigning a value is 10, initial value is 10, b value is 20. We are calling this function. We are calling this function, then the control goes to so function name is SMR. So in this SMR we are declaring only one variable, that variable name is t. Here the memory is allocated for t. So variable name is t, some address 700. So in this function a, b are not declaring. Okay. So whenever the control goes from this main function to SMR, this memory is deallocated, then we will get two errors. One is undefined symbol a and undefined symbol b. So write SMR into t, t is equal to a is equal to b, b is equal to t. While function name is main, into a is equal to 10, b is equal to 20. I am using CLRS here. We are calling SMR and then printf percentage d space percentage d comma a comma b. We have to run this code, we will get two errors, undefined symbol a and undefined symbol b. This one is undefined symbol a, once again undefined symbol b. Whenever we declaring a, b in this function, the memory is a and b are accessible only within this body. Out of this body, this memory is deallocated. That's why we will get an error. Okay. So how to debug this code? Debug. Here I am declaring a, b. Our execution is always starts from main method. So here we are getting an error. Execution always starts from main and then control goes to SMR. But in this code we will get an errors. Okay. So next one is what is the output of while function name is SMR. In this function I am taking the parameters is two parameters, int a and b. So int t, t is equal to a is equal to b, b is equal to t. In this I am taking main method. Within the main method declare two variables, a is equal to 10, b is equal to 20. Here I am calling function name is SMR. So better to take function name is swap. Here is also I am taking swap the two numbers, swap. Here I am passing a comma b. After swapping, print the values of printf. A is equal to percentage d space b is equal to percentage d space a comma b. What is the output of this program? So always execution starts from the main method. So the memory is allocated for main. In this main method we have to declare two variables a and b. So variable name is a and then variable name is b. So every variable some address. Here I am taking 500 and 600. So whenever a initial value is 10 and b initial value is 20. So whenever we are calling the swap function, the control goes to this swap. Then the memory is allocated for so function name is swap. Here a and b are we are passing the parameters. This is called actual parameters. These are called formal parameters. The memory is allocated for a, then b and then t. So variable name is a, this variable name is b, this variable name is t. So every variable has some address. Here I am taking different addresses 700, 800 and then 900. In this, whenever the control goes from main to so this memory is deallocated. This memory is deallocated. In this, b value is copied into b value. So the b value is 20. 20 is copied into this value, and this 10 value is copied into this one. Next, t is equal to a. Here the t initial value is garbage value. T garbage value. Whenever this statement is executed, a value is assigned to t. This garbage value is replaced with 10. Next, a is equal to b. This b value is assigned to this one. This 10 is replaced with 20. Next, this statement is executed. B is equal to t. T value is 20. This 20 is replaced with 10. So whenever the completion of this swap function, once again the control goes to control goes to main function, then this memory is deallocated. This memory is deallocated. So now what is the value of A? The value of A is 10. Next, what is the value of B? Value of A is 10. What is the value of B? 20. Value of B is 20. Here the output is A is equal to 10 space B is equal to 20. So this is the output. This is called call by value. Here we are passing the values. Okay, here A, B are the value. We are passing values. That's why this is called call by value. Here take function name is call by dot C. I am taking function name is swap. This, so swap function I am taking into A comma into B. These are the formal parameters. Okay, so please observe here, actual parameters name is A comma B. A comma B. Here we are giving same names at different names. Okay, these are different variables. If you want, you can take x, y. X is different and y is different. Okay, so better understanding, I am taking x and y. Here t is equal to x, x is equal to y, and y is equal to t. Y is equal to t. So I have to debug this code. X, y, and then t. So మనకు always execution is always starts from main function. First you have to F7. Our execution starts from main function. Windows watch. Okay, whenever the control goes to main function, the memory is allocated for A and B. A value is 10 and B value is 20. Here A value is A value is 10, and B value is 20. So clear the screen. So whenever the swap function is called, the control goes from swap to swap function. This memory is deallocated. That's why A is undefined symbol, B is undefined symbol. B value is copied into X value. That is Y value is 20. This 10 value is copied into X. X value is 10. So observe, whenever control goes from swap to swap function, this one is undefined symbol A and B. This X value is 10 and Y value is 20. Whenever the control goes to swap function, now the memory is allocated for T. The T initial value is garbage value. Whenever the statement is executed, T is equal to X. X value is 10. 10 value is assigned to T. Next, X is equal to Y. X value is 10 is assigned to Y. Y value is, X value is Y. So 20 is assigned to X. Next, Y is equal to T. T value is 10. 10 value is assigned to 10. Now in this swap function, X value is, these two are interchanged. But whenever the control goes from swap function to main function, this memory is deallocated. X is undefined symbol, Y is undefined symbol, T is undefined symbol. The memory is allocated for A and B. Whenever control goes to this statement, the memory is allocated for A and B. So A value is 10 and B value is 20. So Alt F5, the output is 10, 20. This is called call by value. Next concept is call by reference. So what is the output of this program? Call by reference. Here we are passing the address. Here I am writing the swap function. I am writing void main. In this main method or main function, declare two variables, int a is equal to 10, b is equal to 20. b is equal to 20. Here I am using swap function. Here I am passing the address of A and address of B. We are passing addresses. That's why this is called call by reference. Call by reference. Okay. And then printf A is equal to %d space B is equal to %d comma A comma B. I am writing void swap. So return type is no return type void, function name is swap. Here we are passing address of A. That means what type? Address of A means which type of variable? Integer pointer address we are passing. That's why we are using int asterisk ptr1 or p1. Variable name is our wish. I am taking ptr1 comma int asterisk ptr2 pointer 2. Using t is into t, initial value is garbage value, t is equal to asterisk ptr1, asterisk ptr1 is equal to asterisk ptr1 is equal to asterisk ptr2, so asterisk ptr2 is equal to t, is equal to t. So what is the output of this program? So please remember, the execution is always starts from main method. In this main method, the memory is allocated for so name of the function is main. So in this main function, the memory is allocated for A and the memory is allocated for B. So A some address 500. Next this one is B address 600. So A initial value is 10, B initial value is 20. So here we are calling the swap of address of A and address of B. So whenever we are calling swap function, the control goes to swap function here the ptr1 and ptr2 and t. The memory is allocated for three variables. ptr1, ptr2 and then t. So ptr1, ptr2 and this variable name is t. So every variable has some address, taking 700, this one is 800, this one is 900. Here t initial value is garbage value. So please remember, whenever calling this function, first address of b is copied into ptr2. So what is a, what is b? B is 20. What is address of b? Address of b is 600. This 600 is copied into ptr2. So 600 is copied into ptr2. Next, address of a. Here the address of a is 500. This 500 is copied into ptr1. So ptr1 value is 500. Now this variable is pointing to this variable is pointing to this address. Next, this variable is pointing to this address. So here we are passing address, that's why it is called call by reference. Okay. Next, int a, t initial value is garbage value. Next, this statement is executed. So please remember ptr1. What is ptr1? ptr1 is 500. What is asterisk ptr1? So please remember, asterisk is a operator that returns object at that location. ptr is 500. 500 address variable is a. Indirectly a value is assigned to t. That means this value is replaced with 10. Next, asterisk ptr1 is equal to asterisk ptr2. So please remember, ptr2 is 600, asterisk ptr is 600 address variable, that is b, is assigned to asterisk ptr1. What is ptr1? 500. Asterisk ptr1 means 500 address variable, that is a. Indirectly we are assigning a is equal to b. That's why this 20 is replaced here. That means this value is replaced with 20. Next, t is equal to asterisk ptr2 is equal to t. What is the value of t? Is 10. T is assigned to, what is ptr2? ptr2 is 600. Asterisk means 600 asterisk means 600 address variable. Address variable is b. Indirectly b is equal to t. That means this value is replaced with 10. Okay. Next, after completion of this swap, the control goes to main method. Next, this memory is deallocated. What is the value of a? 20. What is the value of b? 10. Here the printing a is equal to 20, b is equal to 10. Okay. So please remember, indirectly in call by reference we are returning two values from the swap function. Okay, so that's why this is called call by reference. So please remember, no return value, that means the return type is void. We want to return single value by using the return type of this function. Okay. by using, if you want to, you have to return more than one value by using call by reference. Okay, so observe this one. Instead of, here I am passing the values, here I am passing addresses. This is the address of A, this one is address of B. Here asterisk into asterisk x into asterisk y. So this variable name is our choice, you have to take any value. So t is equal to asterisk x asterisk x asterisk y asterisk y is equal to t. So debug this code. F7, control always starts from main method. So whenever the memory is allocated for A value is 10, B value is 20, A value is 10, B value is 20. Okay, whenever you are calling the swap function, addresses 0 to 65,535, address of B is stored in Y. Please observe this one, the address of Y is FFF2, address of X is FFF4. Okay, so we are calling T is garbage value, T value is 10, indirectly this function. So please remember, asterisk Y is assigned to asterisk X, indirectly asterisk PTR asterisk X means address at that variable. Y address is B, B address variable is B, that's why. So after completion of this swap function, whenever the control goes to main function, here A value is 20 and B value is 10, this memory is deallocated. So that means indirectly this swap function returns two values from swap function to main function. By using call by reference, you have to return more than one value. In C language, if you want to return more than one value from the one function to another function by using call by reference. F7, Alt F5, output is 20 and 10. Okay, so this is the call by value and call by reference. By using call by reference, if you want to return only single value, by using call by reference, you have to return either single or more than one value. Okay, discussing about call by value and call by reference. Call by value and call by reference. A is equal to square root of some t. So this is called call by value. Next, I want to calculate the power of 2 cube. We have to use, there is a function called power, b comma c. Here the power of b comma c, b power c. Okay, then you have to use power function. In this, square root is a function, power is a function. Here we are passing the values, that's why this is called call by value. This is called call by value. So whenever you have to pass the address, so last classes you have to use there is a function called scanf. So scanf %d space %d comma address of A comma address of B. scanf percentage d comma address of a comma address of b. Next, last class you have to use swap function. So swap of address of a and address of b, and then you have to use the printf statement. Printf, we are using first parameter within the double quotes. This is also a call by, we are passing the address, that is call by reference. So percentage d comma a comma b. So this is called call by reference. Call by reference. Here we are passing the address. Here the address of A and address of B. This is also address. Scanf within the first quotation. This is the first parameter. First parameter should be within the double quotes. This is also called call by. This is also address. This is also called call by reference. But in printf statement, this is called, this is we are passing the address. This is passing value. This is passing value. In this statement, both mixing of call by value and call by reference. Here this is the reference. This is the value. This is the value. So in this function we are passing both call by reference and call by value. So both we are passing. These are the values. This is the address. Every string within the double quotes, any text information is called string. String is always gives base address of an array. This is called base address of an array. So what is array, we have to discuss later. So I will write a small example. Void smr. Here I am taking two variables, int ptr1, int asterisk ptr1, plus plus ptr. It's better to take first variable name is ptr1, second variable name is ptr2. So plus plus star ptr2. This one is ptr1. Next, in main I am declaring two variables. Int a, initial value is 1, b is equal to 1 semicolon. I am calling the smr function. Here I am passing a, here I am passing address of b. So one parameter I am passing the address, second parameter I am passing the value. This is both call by value and call by reference. And then printf percentage d a is equal to percentage d, b is equal to percentage d comma a comma b. So what is the output of this program? So this is main method. In main method, two variables are there, a and b. Memory is allocated for a and b. Variable name is a. So variable name is b. Some address, I will take 500 and then 600. So initial values are 1 and 1. So a value is 1 and b value is 1. Next here we are calling SMR function, then the control goes to SMR. Here the memory is allocated for two variables, ptr1 and ptr2. ptr1 and ptr2. So here addresses are 700 and then 800. So ptr1, here first functions are copied from right to left. First address of B is copied into ptr2. What is the value of address of B? Here the address of B is 600. The 600 is copied into ptr2. The next ptr2 value is 600. Next A is copied into ptr1. A value is 1. That 1 value is copied in ptr1. Value is 1. Here this one is pointer variable, ptr2 is pointing to this address. So whenever the control goes to main to SMR, this memory is deallocated. This memory is deallocated. Next, this statement is executed. So ptr1 plus plus. What is the value of ptr1? ptr1 is 1. Next, this statement is executed. Statement is executed plus plus ptr1. Here the ptr1 is 1, is increment by 1. That means the value is 2. Next, so what is asterisk operator returns object at that location. Here the ptr2 is 600. Asterisk ptr returns 600 address variable B. It returns B plus plus B. Here the B value is 1. This 1 value is replaced with plus plus. That means the B value is 2. Next, after completion of the SMR function, once again the control goes to main function. Next, so this memory is deallocated. Here what is the value of A? Value of A is 1. What is the value of B? 2. The output is A is equal to 1, B is equal to 2. So alt F new F5 F2, file name is reference.c, write SMR. Here I am passing call by value ptr and call by reference into asterisk ptr2. Here I am taking ptr1. Variable names is your wish, you have to take any name. So plus plus ptr1 plus plus asterisk ptr2. Here I am writing main function. In this main function, declaring two variables, A is equal to 1 comma B is equal to 1. So clear the screen, CLRS here, and I am calling SMR function. I am passing A and address of B, and I am printing %D A is equal to percentage D, B is space B is equal to percentage D comma A comma B. So F7 execution is always starts from main function. A value is 1, B value is 1. Whenever we calling swap function, the control goes to SMR function. A plus plus PTR1. PTR1 value is 2. Asterisk PTR. B value is incremented by 1. B value is 2. Whenever the control goes to SMR function, this memory is deallocated. The value of A is 1. The value of B is 2. So Alt F5, output is A is equal to 1, B is equal to 2. Hi everybody, welcome to SMR Telugu Education. సో మనం ఈ వీడియోస్లో పాయింటర్స్ కాన్సెప్ట్ గురించి డిస్కస్ చేస్తున్నాం. ఓకే, సో దీస్ ఆర్ ద పాయింటర్ వేరియబుల్స్. దీస్ ఆర్ ద ఇంటీజర్, క్యారెక్టర్, float variables. This is integer pointer, this is integer double pointer, character double pointer, and a float double pointer. Okay, in this table function declaration is there, then you have to write the function calling. Okay, so void swap int asterisk. This is the integer variable address. So how to write the function calling? In function calling you have to mention the name of the function. So name of the function is swap. Next, int asterisk is address of integer variable, address of I1 and address of I2, and semicolon. This is the function calling. Next, what is the function call for this function? So name of the function is swap. Next, char asterisk, that means character address. So here the character variable is C1, then you have to mention address of C1, then address of C2, semicolon. So this is a char pointer, character address, then you have to write the address of character is C1. This is also character address, the address of C2. Next, so this is the return type is int asterisk, that means int asterisk variable is I1, that means this function returns int asterisk. Here you have to mention the int asterisk variable is some integer pointer 1 is equal to name of the function ABC, then you have to write the char asterisk, that means character address of, if you want you can write directly CPP1 other or address of CP1, both are same. Address of character pointer char asterisk, that means address of C1 or you have to write CP1. So address of C1 and character is C1, semicolon. So this one is valid, otherwise you have to write so IP1 is equal to ABC. So this is called char asterisk. Directly char asterisk variable is CPP1, and then char asterisk variable is CP1 and character is C1, semicolon. This one and this one both are same. Next one is float asterisk is the return type. Then you have to assign the return type variable is fpp. The return type is you have to assign to fpp, pointer, double pointer, is equal to name of the function is smr. Next here int asterisk asterisk, directly have to write ipp1 or address of ip1 comma char asterisk asterisk, address of char asterisk pointer cp1, or directly you have to write cpp1 float asterisk. Here you have to declare the variable as float asterisk fp, float pointer fp. Okay, so directly you have to write fp or address of f1 semicolon. This one also you have to write so return type is float pointer fpp is equal to function name is smr. Next here int asterisk asterisk, directly you have to write ipp1 comma next char asterisk asterisk, then you have to write cpp1 next float asterisk, directly you have to write fp semicolon. So this is the function calling and this function calling, both are same. Next void smr char asterisk asterisk char asterisk, here you have to write the function name smr char asterisk asterisk, you have to write address of cp1 or cpp1 char asterisk, directly you have to write cp1 or address of c1, both are same. Next one, so no return type, function name is xyz int asterisk asterisk asterisk, here there is a no in int asterisk asterisk asterisk, that means you have to here you have to write the address of double pointer, integer double pointer ipp1 or pp2 comma int asterisk asterisk, address of ip1 comma int asterisk, you have to write ip1 or address of i1 next integer i1, otherwise you have to write here ipp. This one also if you want you can write direct integer variable address or integer single pointer is ip1, similarly you have to write here. Next void smr int asterisk asterisk char asterisk char, here you have to write the name of the function is so smr int asterisk asterisk, here you have to write ipp1 or address of ip1, both are same, char asterisk means cp1 or address of c1, next character is c1 or smr int asterisk asterisk, directly you have to write ipp1 next char asterisk is cp1 next char is c1, So this one or this one, both are same. So please remember, whenever you have to write a function, first you have to think about what is the return type, what is the name of the function, and what are the parameters you have to pass it. Okay. Next, based on this declaration, you have to call that function. Or sometimes you know the calling, you have to write the function declaration. Both are same. So next one is, so how to scan a value. One dot C F5. How to scan a number. Void main scan an integer. So int n, you have to ask the in printf enter any number. Enter any number. Scan that value. So scanf %d comma address of n. So by mistake sometimes you have to forget to write the address of n. Directly you have to write the n. And then printf %d comma n. So here n default value is garbage value. Okay. Next here our enter value is not stored in n. It is printed the default value. I want to debug this code. I want to add n. So F7. So n default value is garbage value. I want to enter 10. This 10 value is not stored in the n. You have to print it same value 29 alt F5 minus 29 254. So please remember, here you have to write the operator is called address of n, address of operator. Here I am instead of writing address of n, here I am declaring one integer pointer int asterisk ptr is equal to address of n semicolon. So instead of writing address of n, here I am directly write the ptr, both are same. Whatever the value you have to enter is, here I am writing CLR SCR to clear the screen. CLR SCR alt F5 S F7. So n default value is some value, enter any number. I am entering 100. This 100 is stored in n. Now n value is 100. Alt F5, the output is 100. Okay. Next, write a program to find the sum of two numbers. How to write the sum of two numbers? So void main. So int a. By using pointers concept, you have to printf enter any two numbers. So scanf %d comma address of a. So how to get the next address? We have to add +1 %d comma address of a +1. This is pointing to next address. We have to find the sum of a and b. Printf %d plus %d is equal to %d comma asterisk of address of a comma asterisk of address of a +1 is the next value sum address of a plus asterisk of address of a +1. So I want to clear this screen by using CLR SCR. Clear the screen. So F2, save this one. Alt F9, yes, Control F9. So enter any two numbers 10, 20. 10, 20. 10 plus 20 is equal to 30. So Alt F5, output is 30. Here you have to write this code by using single variable. So by using pointers concept, you have to +1 means it is pointing to next address, but this is illegal. Maybe sometime this program is worked only 90%, not working 100%. Maybe uh, whenever you are declaring a, the memory is full of system, next address is not available. In this case this program is not works, but okay, in our system memory is available, it is work 100%. Enter 100 space 200, 100 space 200, alt F5, output is 100 plus 200 is equal to 300. Okay, so this is the sum of two numbers by using pointers concept, single variable. So next one is here I am taking void main, so int a. Here a is equal to, here I am writing some function which returns the integer pointer. That return type is integer pointer, function name is smr, so no parameters, int a. So a is equal to some value 10, return address of a. So this address of a is stored in, here I am taking this pointer, so ptr, so ptr is equal to smr. So asterisk ptr is equal to some value 30, then printf percentage d comma asterisk ptr. So F2, save this file with the name 1.cs. Okay. So function name is, so return type is int asterisk, function name is smr, so no parameters. So int a is equal to 10, return integer pointer address of integer variable address, address of a. Function name is void main. In this main function I am declaring integer pointer variable int asterisk ptr. So ptr is equal to, I am calling smr, so asterisk ptr is equal to 30, then printf percentage d comma asterisk ptr. Name of the function is main. In this main function we have to declare only one variable, that variable name is ptr. So variable name is ptr. So variable name is ptr. Every variable has some name. Some address 500. Say initial value is garbage value. Okay, whenever we are calling smr function, then the control goes to this main function to here the name of the function is smr. So in this smr function you have to declare only one variable, that variable name is a. Variable name is A. Some address, I am taking 600. So initial value is garbage value. Okay. Next, this statement is executed. A is equal to 10. This value is replaced with 10. Okay. Next, return address of A. So what is A? 10. What is the address of A? 600. This 600 is stored in this return value. So whenever the control goes to main method, this memory is deallocated. This return value, address of A. Here the A is 10, address of A is 600. This 600 is stored in PTR. So 600 is stored in PTR. Next, asterisk PTR is equal to 30. What is PTR? So please remember, whenever the control goes to main method, this memory is deallocated. That means A memory is deallocated. There is no A in our memory space. In 600 is not available. Still we have an address at 600. Okay. Asterisk PTR. What is PTR? 600. What is asterisk PTR? 600 address variable. Asterisk PTR is 600. Asterisk PTR is 600 address variable. A value is 30. So this value is replaced with 30. Okay. Next, printf %d asterisk PTR. What is PTR? 600. Asterisk PTR means 600 address variable, that is A. So value is 30. So this is illegal. So this pointer is, whenever this pointer is called a dangling pointer. We are accessing unreferenced variable. That's why this pointer is called dangling pointers. Okay. So I want to run this code. So Alt F9, yes, Control F9. So Alt F5. Output is 30. You have to clear the screen. CLR, SCR. Alt F9, yes, Control F9. Alt F5. Output is 30. But this is illegal. Maybe this program is not worked 100%. Maybe sometimes this may be failed. Okay. So this is the pointers concept. We have to complete it pointers, arrays and strings and structures and data structures. Every concept we have to repeat the pointers concept. Okay. So still you have to any doubts, please refer our videos. Okay. Thank you.